Okay, here we go. 3.5, solve rational equations. What is a rational equation? A rational equation is an equation that contains a rational expression. It can contain more than one, but it has to have at least one to solve. Now, there's multiple different ways to be able to do this. The easiest way is to multiply both sides by the LCD. I'm going to show you guys what that looks like. We're going to start off with a couple simpler examples. We are going to do some word problems today, so just have that kind of in the back of your mind. Example 1, solve the equation. So A is the problem. 1 divided by x plus 4 is equal to 2. So I'm going to go through. Now I have an equation for the first time this unit. And I'm going to identify the least common denominator. There's nothing to factor here. It's just a very straightforward, kind of simplified example. On the left-hand side, my denominator is x plus 4. And on the right-hand side, I just have 2. Now, I could write 2 over 1 if I was concerned about that denominator, but I'm not. Multiplying by 1 doesn't change anything. So to solve an equation, what I'm going to do is I'm going to multiply every fraction, every number, everything by x plus 4. Now, when I multiply everything by x plus 4, I'm only multiplying things in the numerator. I'm not trying to write an equivalent fraction by multiplying by the top and the bottom. I'm actually changing this. Now, I can do this because I can multiply both sides of an equation by something. As long as I do it to both sides, it stays equal. Just like if I have an equation, I multiply the left side and the right side by 2, everything just doubles, but it's still equal. So I multiply everything on the left by x plus 4 and everything on the right by x plus 4. What's going to happen here is when you multiply everything by the LCD is a bunch of stuff's going to cancel. Namely, all the denominators. Yay! So x plus 4 and x plus 4 on the left-hand side cancel. They go away. And I'm left with 1 on the left-hand side. And then I'm going to distribute on the right. So 2 times x, 2 times 4. Now I just have a straight up linear equation that I can solve. To get x by itself, I subtract 8 from both sides and then divide by 2. Now I can turn that into a mixed fraction or a decimal. I'm just going to leave it as an improper fraction. I'm happy with that, as long as it's simplified. Now, because I've got x's in the denominator, I still have restrictions for my variable. So going back to the original problem, just going to look at whatever I have in the denominator and make sure that that is not equal to 0. The only denominator I have in this problem is x plus 4. So x plus 4 can't be 0. Therefore, x cannot be negative 4. All right. Any questions on A? All right, I would like you to go ahead and try B. Very similar type of problem. Go ahead and using this example, solve B. Okay, it looks like people are done. So for B, least common denominator is just going to be x minus 3. So I'll multiply the left side by x minus 3 and the right side by x minus 3. Now I'm only multiplying the numerator by x minus 3 on both sides of the equation because I have a rational equation is the tip here. This isn't going to work for other expressions. So I get 1 is equal to 5x minus 15 add 15 to both sides, and I get 16 is equal to 5x. Divide by 5, and it's 16 over 5. My restriction is that x cannot be 3. If x is 3, remember that gives me a 3 minus 3, which is 0. 1 divided by 0 is undefined. The whole thing falls apart. Cool. All right, I have a work problem for you. So this one that talks about Arthur and Cheyenne painting a wall. Go ahead and jot that down. Arthur and Cheyenne can paint a wall in 6 hours when working together. Cheyenne works twice as fast as Arthur. How long would it take Cheyenne to paint the wall if she were working alone? The setup for these are probably the most difficult part, but they will always follow the same structure. So if you can understand one, if you have an example, hopefully be able to do all of them. So because Cheyenne works faster than Arthur, Arthur's going to be my baseline, and I'm going to call him X. Now the key here is I have to find some kind of, I'm looking for the rate. So if Arthur can, let's say if Arthur can do a job in 2 hours, picture in your head he can do some job in 2 hours. He can write a paper in 2 hours. How much can he do in 1 hour? Half of it, right? If Arthur can, I don't know, clean his house in 3 hours, how much of it can he get done in 1 hour? A third of it. So everything's in rates. So if it's going to take Arthur X amount of time to paint the wall, then how much of it can he do in 1 hour? That's just going to be represented by 1 over X. That's the rate at which he works. Whatever X is. Now Cheyenne works twice as fast. So if Arthur can write a paper in 2 hours, Cheyenne can do it in 1 hour. She's twice as fast. Now together, I'm adding them, together they work. And they can paint a wall in 6 hours when they work together. What portion of the wall can they complete in 1 hour? 1/6. So here's the setup. That's the tough part. Right? So the first fraction represents the rate at which Arthur works. The second fraction represents the rate that Cheyenne works because she works twice as fast, so times 2. And then this is the rate at which that they're working together to complete the wall. Now to solve a rational equation, I just want to multiply everything in the numerator by the least common denominator. So let's see, I have an X and I have a 6. So I'm going to multiply everything on the left-hand side by 6x and everything on the right-hand side of the equation by 6x. when I multiply the left-hand side, I have an expression. So I'm going to have to distribute this through. I'm going to go slow here. I'm going to multiply and then simplify in a minute. So I get 6x times 1 is 6x. 6x times 2 is 12x. Now you could multiply and simplify at the same time. Just trying to go slow for the first one. And then when I take a closer look at those fractions, I have 6x over x. Oh, the x's cancel. 12x over x. Oh, the x's cancel. Remember, when I multiply everything by the LCD, all the fractions should cancel. I should have no denominators left. 6 divided by 6 cancels. So what am I left with? 6 plus 12 equals x. The x equals 18 means that it takes Arthur 18 hours. That means that he completes 1/18 of the wall in an hour. The question asks, how long would it take Cheyenne? Cheyenne works twice as fast. So if it takes Arthur 18 hours, that's a really long time. That's a big wall. Or maybe it's a small wall with a lot of detail in a mural. But if she works twice as fast, that means it's only going to take her 9 hours. You'll see another example similar to that in your review. Okay. So this idea of extraneous solutions, we've come across this before. We're coming across it again. I think the first time we talk about extraneous solutions is in Math 2. An extraneous solution is the solution found that is not an actual solution of the original equation due to an exception. Hint, we're going to be comparing it to restrictions. So jot that definition down, and then example 3, solve the equation. And we'll work that out together and take a look at how extraneous solutions affect the answer. So example 3, solve the equation a1 divided by x minus 5 plus x divided by x minus 3 equals 2 divided by x squared minus 8x plus 15. Before finding and identifying the least common denominator, I'm going to want to factor all my denominators to make sure that I have all the pieces. So when I rewrite this in factored form, x squared minus 8x plus 15, the two things that multiply to x squared is x times x. Two numbers that multiply to 15 and add to negative 8, minus 5 and minus 3. So then I identify the least common denominator. Okay, in my denominators, I have an x minus 5. I need that. Got it. In my denominator, I have an x minus 3, so I need that in my list. Got it. Now, the denominator on the right-hand side, I have an x minus 5. It's already on my list. I have an x minus 3. It's already on my list. So I'm going to multiply the entire left-hand side of the fraction by the LCD. And the entire right-hand side of the fraction. I'm sorry, the entire right-hand side of the equation by the LCD. Now, if you're good at keeping things organized in your head, you might be able to skip some steps here. I'm going to write them all out. Because I have to basically take this, I have to take this LCD and I have to distribute it. So I've got x minus, try that again, x minus 5 times x minus 1 times 1 over x minus 5. And then I multiply it to the next one. So write this down and then I'll break and make sure that we're okay on everything that happened so far. It's a lot of writing. But all I've done is I just distributed this LCD, this x minus 5 times x minus 3, to both of these. So I just wrote it twice. A little tedious. Not too complicated. Are we okay at this point? I haven't really done anything except for just multiply by the LCD and rewrite some stuff. Now I'm going to go through and I'm going to simplify. Like I said, you could probably jump from this step to the next step I'm going to do, but... So now when I take x minus 3 times x minus 5 times 1 over x minus 5, the x minus 5s cancel. That leaves me with just x minus 3. I have a plus sign. In my second fraction, I have x minus 3, which cancels with x minus 3. So I'm left with x times x minus 5. And on the right-hand side of the equation, x minus 5 cancels and x minus 3 cancels and leaves me with a 2. I'm going to work through and multiply and simplify the left-hand side. This time I have a quadratic instead of a linear equation, so it's going to take a bit more work. So when I distribute the x, I have x squared minus 5x. X squared, combine like terms, I've got minus 4x. And before I solve a quadratic, we are in the habit of setting that equal to 0. So I'm going to solve for 0. So the rest of it is a flashback to Math 2. And I know we're still rusty on some of those skills. But take a look back through and see if you can follow my steps for this point before I finish it. So we factored the denominator, found my LCD, multiplied everything by the LCD. In that process, I had to distribute, and then I canceled out everything that I could cancel, which left me with this, which just happens to be a quadratic equation. I solved it for 0. The next part is actually exactly what we're doing in Math 2 right now. To solve this quadratic, I have options. I can factor or I can use the quadratic formula. This is factorable, so I would certainly choose factoring over the quadratic formula. It's way less work. This factors to x minus 5 times x plus 1. So I'm looking for the two numbers that multiply -5 and add to -4. Now, if x minus 5 times x plus 1 is equal to 0, I can take both of those factors and set them equal to 0 and solve for x. We okay on that last part? Factor solve? Hopefully. Now, those are actually not both answers. So let's go back and talk about the whole idea of an extraneous solution, right? So an extraneous solution is a solution found that is not an actual solution of the original equation due to an exception, in this case, a restriction. So when I go back and I look at my restrictions, I get that x cannot be equal to, let's see, x minus 5 gives me the restriction of positive 5 and x minus 3 gives me the restriction of negative 3. I have the same ones for over here. Oh, positive 3. Whoops. X minus 3 gives me the restriction of positive 3. So now my restrictions and my answer are at odds. Well, I just did all this work and I found that my solution is x equals 5 and x equals negative 1. But my restriction says, but x can't be 5 or 3. If x is 5 and I plug in 5, I have 1 divided by 5 minus 5, which is 0. Doesn't exist. It's undefined. X equals 5. It's what's called the extraneous solution. It doesn't count. It's like rejected, denied. So the only answer is x equals negative 1. That problem's a lot. That's about the hardest it'll get on your test. Don't worry, we're going to do some more practice. All right. Let's take a look at B. I'm going to do another one. B is 5x divided by x minus 2 is equal to 7 plus 10 divided by x minus 2. So let's try you guys doing the first step. So step 1, find the LCD and multiply everything by the LCD. Go ahead and just do that step and then we'll pick up together. Identify the LCD and multiply everything by the LCD. See what you can get to cancel. See what you have left. B is a little simpler than A, so don't be deterred by trying.
Only want to multiply the tops by the LCD. I'm not changing the bottoms. So when you multiply the top, it's cancelled. When you multiply the top, it's distributed. When you multiply the top, it's cancelled.
So the least common denominator is just x minus 2. That's it. I have it on 2 of my fractions. So I'm going to multiply everything by x minus 2. So I multiply the entire left hand of the equation by x minus 2 and the entire right hand equation by x minus 2. When I multiply the left hand equation by x minus 2, those cancel and I'm just left with 5x. When I distribute this through, I'm going to have 7 times x minus 2 plus 10 over x minus 2 times x minus 2. You can skip some steps here if you can see how that can cancel, and you can write less. So I have 5x on the left side, and then 7 times quantity x minus 2 gives me 7x minus 14. And then that last fraction, x minus 2's cancel, and I just have plus 10. Ooh, no quadratic term this time, just linear term. Minus 14 plus 10 is minus 4. And I'm just going to solve for x. So I want to get all my x's together on one side. And get x by itself. Negative 4 divided by negative 2 is a positive 2. When we compare that to my restrictions, right here, my expression with variable in the denominator is x minus 2, which means that x cannot be 2. But I just found that x is 2. And because I only have one value of x, and that is an extraneous solution, I have no solution here. Extraneous. So x equals 2 is called an extraneous solution because, yes, when I work it out, it should be an answer. But then it's also a restriction, so it doesn't work. All that work to get no solution. All right, problem C is very similar to problem A. One more of these examples before we do a word problem to finish off today. So on C, I'm going to start you off and then ask you to finish it. Here it is. 3 divided by x minus 3 equals x divided by x minus 3 minus x divided by 4. So my least common denominator, I need an x minus 3. I also need a 4. So I'm going to multiply everything on the left-hand side by my common denominator. And everything on the right-hand side by my common denominator. Now you can kind of choose here. I could write it next to every fraction, or I could write it next to one fraction and then distribute. So I'm going to do this one just so it looks a little differently. They're the same result. I'm still multiplying everything by the LCD. This one's got a couple things that makes it a little complicated. I've got more than one piece for my LCD. I also have a subtraction sign to need to be aware of. If I multiply every fraction by the LCD, or every rational number by the LCD, it's a little easier to see what cancels. So I have x minus 3 and x minus 3 cancels. 4 times 3 is 12. Equals x minus 3 and x minus 3 cancels. 4 times x is 4x. The 4 and the 4 cancels. And now I got to be a little careful because I have a negative in front of that x. So negative x times x is minus x squared. And negative x times negative 3 is a positive 3x. So I'm going to give you a hint, and then I'm going to ask that you try to solve from here. I have a negative x squared. I am going to suggest that you combine like terms, move everything over to this side so that you have equals 0, and then solve from there. Combine like terms, move everything to the left-hand side so you have a quadratic is equal to 0, and then solve from there. Try to finish the problem. as you work this out, when I rearrange my quadratic and get it on all one side of the equation, I have x squared minus 7x plus 12 is equal to 0. So I did that by just combining my like terms, 4x and 3x, moving it to the left-hand side, and moving my squared term to the left-hand side. From here, this is a factorable. The left-hand side is a factorable expression. So I factored into x minus 3 and x minus 4, which gives me solutions for x as 3 and 4. When comparing to the restrictions, the only restriction that's created in the denominator is that x cannot be 3. Remember, if I just have a number in the denominator, that does not create a restriction on x. Therefore, x equals 3 is what's called the extraneous solution. And the only one that counts is x equals 4. So we have this word problem next. All right, example 4, paddling with the current in a river. Jake traveled 16 miles. Even though he paddled upstream for an hour longer than the amount of time he paddled downstream, Jake could only travel 6 miles against the current. In still water, Jake paddles at a rate of 5 miles per hour. What is the speed of the current in the river? So, a lot of detailed information here. The setup is going to be the toughest part. When you're doing one of these distance, rate, and time problems, my recommendation is to create a table. So, let's look at that. I'm going to make a row for downstream. And a row for upstream. And we are talking about distance, rate, and time. One of the things that we're going to need to use here is the knowledge that time is equal to distance divided by rate. And then I've got to go through and fill in all of this information. Okay, so the problem says paddling with the current in a river, Jake traveled 16 miles. All right, so he goes downstream 16 miles, and he comes back upstream 16 miles. So there and back kind of situation. Now, in still water, Jake paddles at a rate of 5 miles per hour. Now, if he's going downstream, all right, then he will be going 5 miles per hour plus whatever the current's taking him. So he's paddling 5 miles per hour if the water isn't moving. So if he's going downstream, that means he's going to be going 5 miles per hour plus whatever current is taking him in that direction. So we're going to call this 5 plus C for current. Which means when he's paddling upstream, the opposite effect is happening. So in still water, he paddles 5 miles per hour. Now he's going upstream, so the current's working against him. So I'm going to subtract the speed of the current from the rate at which he's going upstream. All of that comes from my descriptions here. Now, time is equal to the distance divided by the rate. So I'm going to get my time by doing the distance divided by the rate. So the time upstream is going to be 16 divided by 5 plus C, which doesn't have a lot of meaning right now, but we'll put meaning to it. And then the time upstream is going to be 16 divided by 5 minus C. Now I want to write an equation where I have the amount of time spent going downstream is equal to the amount of time spent going upstream. But they're not equal times, right? He can't go 16 miles upstream and 16 miles downstream in the same amount of time. So there's another piece of information in here that I'm going to need. In the problem, it says, even though he paddled upstream for an hour longer than the amount of time he paddled downstream. So I'm just throwing up some numbers out here just to try to make this make sense. Even though he paddled upstream for an hour longer than he paddled downstream. So if he went downstream and it took him 8 hours, then it took him an hour longer to go upstream, yeah? All right. If he paddled downstream and it took him, 6 hours, then to go upstream, it takes him an additional hour, yeah? In order to make this equation equal, I have to add an hour to the downstream time. So here, this is downstream. This is upstream. In order to make this equal, I have to add an hour to the downstream time. Woo! Writing the equation is the hardest part. Next, I get to solve. So, a rational equation. I find my least common denominator. Well, all the pieces of my denominator are 5 plus C and 5 minus C. So I'm going to multiply everything by my common denominator. I'm going to reduce everywhere possible. I'm going to multiply through. I'm going to combine like terms and move everything to one side of the equation. So let's see, I've got 80 and 25. A lot of movement going on. Oh, I have an error on here. No wonder this isn't working. This is a 6, not a 16. Sorry, the problem says 6, and I wrote a 1 in front of it. Fix that. We've only got a minute left, so I'm going to rush through this a little bit, and I'm sorry. The video will be posted for you to see. But when I factor this, I get C plus 25 and C minus 3, which gives me C is either negative 25 or 3. Well, the current doesn't run at negative 25 miles per hour. Because this is actually extraneous. So I get that the current runs at 3 miles per hour.